So for number 56, we want to express this number here as a ratio of integers. So we have that 7.12345 repeating. Well, that's just going to be 7 plus 0.12345, and then 1, 2, 3, 4, 5, and so on and so forth. So let's take a look at this expanding decimal, and let's express it as an infinite sum. So that's just going to be 0.12345 plus 0. We're going to put zeros in all the previous ones and then go 1, 2, 3, 4, 5, and last one 0 point, and that's going to be 10 zeros, so 3, 4, 5, and then 1, 2, 3, 4, 5, and so on and so forth. And that works out because if we were to sum it up, we could just see that that's just going to be 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and so on and so forth. Okay, so once we're here, what we can notice now is that each of these terms can be expressed as a power. And the reason that we want to express it as a power is because if we can express it as a sum of powers, well, that's just a geometric series, and we have a way to calculate that. So this one's going to be 1, 2, 3, 4, 5 times. We have 5 decimal places, so that's going to be times 10 to the minus 5. The next one is going to be 1, 2, 3, 4, 5 times, that's going to be 10 to the minus 10. The next one's going to be 1, 2, 3, 4, 5, and that's 15 decimal points. So that's going to be times 10 to the minus 15. And, oops, let me rewrite this, and so on. So what we can see here is that this whole thing can be expressed as the sum from n is equal to 1 to infinity of 1, 2, 3, 4, 5 times 10 to the minus 5 times n, because, let me make that better, because if I plug in n is equal to 1, for my first term, it's going to give me 10 to the minus 1 times 5, which is minus 5. That checks out. If I plug in n is equal to 2, that's going to be 10 to the minus 5 times 2, minus 10. N is equal to 3, that's going to be 10 to the minus 15. So that works out, right? So once we have expressed this, we are almost good to go, except that we want to turn this into just 10 to the power of n, so we want to simplify this a little bit. So to simplify this a little bit, we can notice here that that's the same thing as saying the sum from n is equal to 1 to infinity of, we're going to get rid of this minus, so that's going to be 1, 2, 3, 4, 5, and that's going to be 1 over 10 to the power of 5 to the power of n, right? And so this is 10 to the power of 5 to the power of n, and instead of doing that, we can just raise this whole thing to the power of n. So that's going to be 10 to the power of 5 to the power of n. And 10 to the power of 5, that's going to have 5 decimal places. But we can just leave it this way for now. That's fine. So once we have been able to express it this way, we can look at a geometric series, the formula, so that goes from n is equal to 1 to infinity of ar sub n, and that's going to be a sub 1 divided by, ar to the power of n, 1 minus r, if the ratio is less than 1. Now the ratio here, the ratio is the thing that's being raised to the power of n. That's 1 divided by 10 to the power of 5, which is definitely less than 1. It's a very small number. So that definitely checks out. And now since that checks out, we can now use this formula here over there, which will give us our sum. So this formula is going to be a sub 1, and a sub 1 is just whatever you get when you plug in the first index. So the first index, I'm going to have 1, 2, 3, 4, 5 times 1 over 10 to the power of 5 to the power of n. So that's going to be times over 10 to the power of 5. And maybe I'm just going to write this the expanded version. So that's going to be 1, 2, 3, 4, 5. So that's a sub 1, right? All over on the denominator is 1 minus the ratio. So that's going to be 1 minus, the ratio is 1 divided by 10 to the power of 5. So that's going to be 5, that's 1, 2, 3, 4, 5, 5 zeros. So we can simplify that as being, that's going to be 1, 2, 3, 4, 5 divided by 3, 4, 5 here, all over 1 minus 1 divided by 100,000 is just going to be, it's going to be 99999 over 1, 2, 3, 4, 5, yeah. And so, if we notice here that these have the same denominators, well, that's just going to be 1, 2, 3, 4, 5 over 99999. So this is the result of this sum here. That's the whole infinite expansion. So going back to our infinite expansion, what we can then say is that 7.12345 expanded is the same thing as 7 plus the sum from 1 to infinity of 1, 2, 3, 4, 5 times 1 over 10 to the power of 5 to the power of n, and that's just going to be 7 plus 1, 2, 3, 4, 5 divided by 99999, and now we have to plug that into our calculator. So let's see what that gives us. 7 plus 1, 2, 3, 4, 5. So that's, if we join these fractions, that's going to give us 237,446 over 33333. So this is the final answer when we sum up 7 with this fraction that we got, which was 1, 2, 3, 4, 5 over all these 9s. So that's it for our final answer.